All right, you guys, 11.6 natural logarithms. Only one more lesson after this, and then we're done with chapter 11. Woohoo! All right. So the natural logarithm is the logarithm that goes with e. So ln of x, this is called the natural logarithm. It is the same as log base e of x. So a logarithm base e is the same as ln of x. This is called the natural logarithm. Okay, so if ln of e equals x and e to the x equals 1, then x equals 1. Therefore, ln of e equals 1. This is the inverse of e, ln of e. Okay. All right. We're going to talk about equations involving e and undoing them with an ln. Okay, so our example, this is some information from the beginning of the chapter. If you want to look at the top of page 733, it gives you some information about rumor spreading and an equation that represents that sociologists have found. Kind of crazy. So the rumor equation to determine the fraction of people is P equals P0 e to the kt over 1 minus p to the 0 times 1 minus e to the kt, where t equals days. PO is the fraction of people at time 0, so the initial amount of people. K is a constant that will either be given to you or will have information given to you to find the constant. Okay. Remember, E is that number between 2 and 3, so it's a number on your calculator. All right, so we'll use this equation in this example. It says, in a particular study, sociologists determine that at time t equals 0, 5% of the population in a group have heard a certain rumor. After 2 days, 25% of the people in the group had heard the rumor. How long will it take for 80% to hear the rumor? Okay, so we're going to use this equation up here. The first thing is we could write these things out. So how long will it take for 80% of people to hear the rumor? So that's the time that we want to find. PO is the fraction of people at time equals 0. So at time equals 0, our PO is going to be 0.05. Okay. We're looking for a T, so our P is going to be 80%, so 0.80. Okay, that means that we need a K, which we don't actually know because the goal is to find out what our time is. Right? So we need to use the information given to find a K so that we can then find the time of our 80%. Okay? All right, so first what we're going to do, I need this stuff too. Okay, first we're going to do is find the constant K. Okay, so we're going to use this after 2 days, 25% of the population. So we know that PO is still 0.05. We know that P is going to be 25%, and our time is going to be 2 days. And that information we're going to use in the equation to find out what our constant K is. So our change pretty much. Okay. Oh. Okay. So our equation is P equals PO times E. We don't know K. Time is 2. over 1 minus PO, 1 minus e to the kt. All right, so we're gonna have lots and lots of algebra to do to find this. All right. Okay, first thing I'm gonna do is multiply both sides of our equation by this so that we can get rid of this. Okay. We could distribute this 0.025 into here, so we have some less things to worry about. So I might do that first. So 0.25 equals 0.05 e to the 2k. It's going to make my equation a little more organized. 1 minus 0.05 times 1. I have minus minus, so plus, oh, this t should have been a 2, plus 0.05 e to the 2k. Okay. We could subtract this, so we could get a 0.95. So I'm going to multiply both sides of my equation by 9.5 plus 0.5 e to the 2k. Okay. So that we can solve for k. Okay, on this side, I'm going to have this times this 2.5. So I'm going to have 0.2375. Why I'm distributing this 0.25 to both my pieces. And this should be an 0.5. Plus 0.0125 e to the 2k. Sweet. Now I'm going to get e to the 2k on one side. So this is going to technically go away. Okay. Because these have the same e to the 2k, we can just subtract them. So we need 0.05 minus 0.0125. So we'll have 0.0375 e to the 2k. Okay, let's get e to the 2k by itself. So far we've only really done a little bit of complicated algebra. Okay. So 6.3333 equals e to the 2k. All right, so now to get this 2k out of here, we're going to take the ln of both sides. Okay. Why we're going to take the ln instead of the log like yesterday is because this is a base e. If we take the ln, that's the same as taking log of a base 10. Okay, so pretty much this will go away, and we'll have ln of 6.3333 equals 2k ln of e. Okay. Ln of e is just equal to 1. So we can make that go away. We'll divide both sides by 2. And we'll get that k equals whatever that is. So ln is approximately 0.9229 is our k. Okay. Awesome. So now we found our k, which we're going to need to plug back into this equation using this information. So now we know, see if I can find my other color. It's disappeared. Okay, here's one. Now we know that K is 0.9229. We found that below. So now we can plug into this equation to solve for the time at 80%. Okay? So we know that we're going to have 0.80 equals, going back to our equation up here, PO is 0.05, e to the kt, we know our k, it's going to be 0.9229t over 1 minus 0.05 times 1 minus e to the 0.9229t. Okay, now we pretty much get to do the exact same thing again, but this time we're solving for t. Okay, so let's make this a little bit less complicated. We're going to simplify the bottom a little bit so we can distribute this to both of our pieces. So we'll have 1 minus 0.05 minus a minus would be a plus 0.05 e to the 0.9229t. Okay, 1 minus 0.05 is going to be a 0.95. On both sides. Whoop. Gonna have to cram it in here. Two, 9t. Okay. Okay, so this goes away. On this side of our equation, we'll have 0.05 e to the 0.92299t. And on this side, we're going to distribute, so we'll have 0.95 times 0.8. So we will have 0.76 plus 0.05 times 0.8, 0.04 e to the 0.9229t. Right. We have this same thing on both sides, so let's subtract it. E to the 0.9229t. Okay, this goes away. So we'll have 0.76 equals 0.01 e to the 0.9229t. We will divide both sides by 0.01. Okay, so we'll have 76 equals e to the 0.9229t. Okay, so we have a base e. We want to get this down, so we're going to take the ln of both sides. So we'll have 0.9229t equals ln of 76. Divide both sides by 0.229. Sorry, 9229. And our time is going to be 76 divided by 0.9229. Okay, our time looks like it is 4.6925 days. Okay, or we could round it and say that 80% 80% will hear in 4.7 days. Oh, I didn't do all my math so you could see it. Okay, there you go. I know you guys love when I do that. All right. Today we have like a very few amount of concepts. So, next thing, logarithms with a base other than e can be converted to the natural logarithm using the change of base formula. All right. So just like we did change of base formula before for log base 10, we can also do it for natural logarithm. Okay. All right. So if we have this, okay, our change of base formula would be the log of this divided by the log of this, right? So we're going to do log base e of 254 divided by log base e of 6. Okay. We know that log base e is just ln, so we can do the ln of 254 divided by the ln of 6. Okay, just kind of a heads up, I learned change of base and doing that a lot with log base 10. In calculus, I've noticed this year that a lot of it is done with ln. So just get comfortable working in ln because it's something that they do in calculus a lot. Okay. So now I just plug this into our calculator and we'll get that this is approximately 3.0904. Okay. Thank you, change of base formula, for getting us this answer. All right. If we did it in log base 10, we would still get the same answer. Because we both have ln's here. That's why. All right. Page 2. 3 more examples and then we're done. Okay. So this one says, solve this. Okay. Last time we talked about the anti-log being just 10 to the x. Well, the anti-ln is just going to be e to the x. So we'll see that pop in today. There is an e to the x built in your calculator above the ln, so you can use that, or that's it. Okay. So solve this beauty. Okay, so what we're going to do, we're going to get ln of x by itself. So let's divide. Oh, well, I guess I'll just write it right on the example. Okay, so we'll have ln of x equals whatever this is. We'll just punch in our calculator, 6.5 divided by 16.25, which ends up being negative 0.4. Okay. So then you'll just plug this into your calculator pretty much of in order to get rid of a logarithm. How I do it is I just add an e to the ln of x and this e to that power. So this gets rid of the ln, and if you type in e, okay, e to the negative, that'll be the answer. So the answer is approximately 0.67. Okay, this is how I've honestly remembered to do it. Make these both an exponent. All right. Okay, next problem. Solve for x. So the first thing I'm going to do is, there's no solving I can do. So what I'm going to do is I'm going to take the ln of both sides. By doing that, I can now bring my exponent down. Okay, we kind of did this already with our logs, but now we're just doing it with an ln instead. Okay. Honestly, instead of adding a bunch of numbers and decimals, I would just leave them in their ln form, and then you can just punch it into a calculator at the end. So I'm going to have to distribute here. So I'm going to have x ln of 7 minus ln of 7. Okay. I want to get all the x's on the same side. So I will move this. So I'll have 2x ln of 3 minus x ln of 7 equals negative ln of 7. Now I need to pull an x out of both of these. So 2 ln of 3 minus ln of 7 get x by itself. Now I'm going to just divide. Both sides. So x is going to equal whatever I punch into, whatever that is, thanks to our calculator. So I'll go negative ln of 7 to parentheses divided by. Now I need to make sure all of this goes in the bottom. It's going to want 2 closed parentheses, and it's going to equal that. So negative 74.3. Okay, my answer is a little different from the book because they round our ln's all the way up here. They took a round of them. So in the book it says that the answer is negative 74.33. But what's actually interesting, we'll pull this over here. They did a second method by graphing. So this is the method they got algebraically, the number. And then when they graphed it, they got the actual same answer that we got. So this is a good example as to why we don't round these numbers early on. There you go. Whoop. Okay, last problem. Yeah, I wrote it all silly. So, okay. So when there's an inequality, we solve exactly the same. Okay, so what I'm going to do is I'm going to take the x, whoop, I already made that mistake. Okay, 6x squared minus 2, 48. I'm going to take the ln of both sides. So I can take this down. So I'm going to have x squared minus 2 times the ln of 6. Remember, the ln of something is just some number. Okay, I want to leave it as ln of 6 because, like that last problem, when you round, you can lose some decimals. When it's out to 4 significant figures, not as big of a deal, but I would rather get exactly the same answer as the graph than be off. All right, put that here. We need to distribute, so we'll have ln 6x squared minus 2 ln of 6 is less than ln of 48. Okay, we're going to work to get this number by itself, so I'm going to add this to both sides. Okay. We'll have ln of 6. I probably actually should write it x squared ln of 6 is less than ln of 48 plus 2 ln of 6. Remember, you can just punch this in your calculator. I'd leave it as is for now. All right, so whatever that is, maybe I find that answer now before I take the square root, just because it's getting a little bit messy. Okay, we need to make sure and do this whole top first. So we're going to do ln of 48 plus 2 ln of 6. We're going to make sure and put our parentheses. I forget that it auto makes parentheses for you. So this is approximately whatever, 4.160,558, okay? Then I'll square root both sides. I left my answer in my calculator, so I can just put my square root in second answer. So x is going to be less than, we've been rounding to 4 digits, 397. Okay, because this is, we square rooted, we need to have our plus or minus there, which means that when we do that minus, we actually need to flip our sign. So there's our minus. Okay. So our inequality is going to be negative 2.04 is less than x, which is going to be less than 2.04. All right, so there's your answer. And it's just barely in the picture. Woohoo! All right. Homework. Page 736, 19 to 47 odd. Okay. This is score due to me by Sunday. Please. Okay. So we'll have these 2 lessons this week, and then next week we'll have 1 lesson, quiz, and then your kind of end of chapter 11 project. Please send me an email if you have any questions, and have a wonderful week.